Hey friends, welcome back. So what we have been doing up until this point is we have been preparing the environment and the various building blocks. So in this video, we are going to be deploying Nutanix Kubernetes Platform in an internet connected environment. So I'll be walking you through how to create your first image, then how do we populate the registry, after which perform a deployment of Nutanix Kubernetes Platform. I will also have a subsequent video for air-gapped environments. So without further ado, let's get started. So the first step, what we want to do is we want to download the air-gapped bundle for Nutanix Kubernetes Platform. So we can head over into portal.nutanix.com, head over into downloads, go to Nutanix Kubernetes Platform, and look for the air-gapped bundle. So we see that this is 2.14.1, and the latest version is 2.15.0. So I'm just going to click on the three dots over here and click on copy download link. Then I will SSH into my jump host, which is at 100.3. And all I'll do is I'll just do a curl, follow redirects and output file, and paste in that file name. So we just wait for the download to complete. So now the download has completed, we will decompress the file. Now that that's done, we can change directories into the nkp v215 folder and copy the nkp CLI into our /user/bin. And we get an nkp CLI version, right? So that works. Next, what we want to do is we want to load a couple of images that is available inside the air-gapped bundle. So the first one is our Convoy Bootstrap image. And the second one is our nkp image builder image. So as we can see, our Ubuntu user has constantly been using the sudo command in order to run any of the Docker commands. So let's change that by running a couple of commands to configure the Ubuntu user to be able to run Docker commands. So that's a sudo group add docker. Add the user into the Docker group. New group Docker to refresh the group memberships, and let's see whether we can run without any sudo. It works. The next step will be to create a base image that we're going to be using to create a cluster API compatible image from. So over in Prism Central, I've already downloaded the Ubuntu 22.04 installer image, but if you wanted to do that, you can head over to the releases.ubuntu.com/gemi for 22.04. Right click on the server install image, copy the link address, click on add image URL, and add the URL. I like to remove the suffix, then click on next and save. And then what that will do is we'll upload the ISO into all the clusters. So I have already done that. I won't redo it again. We head over into the VMs page, create a VM. I'll call this Ubuntu 22.04 image. Then I'll select a cluster to deploy on, give it some CPUs and memory, clone an image from the downloaded ISO, and give it 80 gigs of storage space. Now, why 80 gigs? So the default installation of Nutanix Kubernetes Platform, where we deploy a control plane or worker node, it automatically uses 80 gig, right? If you don't specify anything. So that's a default if we don't specify a size. So if we were to create an image that is larger than 80 gigs, what's going to happen is that the installation will fail, the deployment will fail, because the original image size is more than 80 gigs as the default. So what we want to do is we just specify it as 80 gigs first, and later on, subsequently, we can always specify a larger worker node size. And I've got a script that automatically resizes all the partitions if we give it additional space. We'll attach it to a subnet and create the VM. So I won't run through the installation steps, right? That's pretty straightforward. There are a lot of tutorials out there that shows you how to do that. But what I'll do is I'll stop at the partition page because I want to partition it in such a way that is CIS-compatible. So here is where we start to set the custom storage layout. So I'll use custom storage layout. Under the free space, I'll add a new GPT partition. I'll set it to /boot, and I'll use 1 GB. Then for the additional free space, I'll create a GPT partition, but I do not want to format it. that will create a LVM for that partition. So with that, what we can do is we can start to create the individual partitions for the various mount points. So this gives us a logical volume layout that can meet CIS requirements. And this is something that we see typically in customer environments. So I'll go ahead and carry on an installation. Okay, now that the virtual machine has completed installation and finished its boot up sequence, we can go ahead and perform some configuration changes on it. So we head over our terminal, can SSH into it. The first thing that we want to do is we want to make changes to our FS tab so that we can mirror the CIS benchmark configurations. Then now that that is done, we can go ahead and reboot the VM. VM is back online and you can SSH back into it. Now if you take a look at our mounts, we see all our mounts mounting with the correct mount options. Now the next step would be to configure it in such a way that it will automatically resize itself. So I have got the commands over here. We can just copy everything over here and paste it in. So what this does is that it creates a unit that automatically runs this script over here that will resize our partitions if we provide it more space. This is a very easy way for us to just add on additional drive space to the virtual machine, and it will automatically pick that up and resize the partitions for us. Now this will only run one time, so we need to make sure that we generalize the virtual machine, and anytime we make a change, then only that's when the size of the mounts will change. So we also need to ensure that the logical volumes are named correctly. So if we take a look, LV root, that's correct. LV var, that is correct. LV var log, that's correct. And LV var log audit, so that is correct as well. So once that is done, we can go ahead and generalize the virtual machine. Great. And once that is done, we can power off the VM. So once the virtual machine is powered off, the next thing we can do is we can create a image out of that particular virtual machine. Okay, so the image has been powered off. I'll just go over to images, add an image from a virtual machine disk, and I'll select the Ubuntu image, select the drive, click on the plus, and I like to remove the suffix, keep things clean, next, and save. Great, so the image has now been created. So we can test to see that the image is working as expected. We will create a new virtual machine, call it resize test, management cluster, for CPUs 8 GB of RAM, attach a disk, and I'll clone from the image we just created. Instead of 80, I'll just select 200, and I'll attach it to a subnet. I'll use Cloud Init as well to ensure that my Cloud Init is working as expected. Next, and create. Then we can power on this VM. So VM is booted up. We can SSH into it. And if everything works, we don't need to key in a password. So if we ls blk, we see that the partitions has automatically been resized, and the volume group has also been automatically resized. So that looks good. So now that that is done, what we can do is we can go ahead and build our cluster API compatible image from the image we just created. So it's over here. I've got all the commands already detailed out. I've already exported my Nutanix user and Nutanix password. So I'll just go ahead and export the rest of the environment variables. So back to my jumpos, I'll just fill up the environment variables. The first one is Prism Central IP or FQDN. So it could be your IP address of Prism Central, or it could be the actual FQDN. I'm just going to use the FQDN. Then the Prism element cluster where the build is going to happen. So I'm going to use my management cluster. The subnet that we're going to be using. the source image, which is the image that we created earlier, the size of the disk. So the disk that we are going to be using is 80 gigs. The image is 80 gigs, so I'm just going to specify 80 over here. And the export packer var remote folder. This is only needed if you are using CIS level 1 or level 2 partition layout and mount points. And this is because CIS level 1, level 2 has got a /temp which has got no exec. Right, so once that is done, we can then go ahead to run the command to build the image. So now the image build has completed. We see we have got an artifact. This is the image that we have. And if we go over into Prism Central, we will see that that image is now listed as available, right? So same image name. So the image is really just nkp Ubuntu, the version of Ubuntu, the version of Kubernetes that is included within the image, as well as the date and timestamp of the image. So we can then go ahead and use this image to create a Nutanix Kubernetes Platform cluster. So what if we wanted to use GPUs with Nutanix Kubernetes Platform? We will need to create a cluster API compatible image with the GPU drivers injected into it. So we have got two ways of doing so. The first one is to bake the NVIDIA drivers directly into the BaseOS. So the image that we created earlier, the one with the vanilla installation of Ubuntu, we need to attach a GPU to it. After that, install the NVIDIA GPU drivers. I won't be covering that in this blog post nor the video. There are many tutorials out there in YouTube that you can follow. The other option is to use Nutanix Image Builder, and we specify an additional variable called GPU name, and this will automatically attach the GPUs to the image and install the NVIDIA GPU drivers. There are two types of commands that we can run. The first one is if you don't have CIS partition layouts, so you can just go ahead and just run that. We shouldn't have any issue. If you have CIS partition layouts, which I do, right, we will need to use the script over here to modify the Ansible scripts so that it will work with CIS. So I'll go ahead and build an image. Same environment variable, same username and password. The only thing that we need to change is the GPU name. So the GPU name is from Prism Central. I can head over into my GPUs. I see I have got 4 GPUs over here. Can then go over into my terminal, paste the commands in, and change the GPU name to the one that I have. There we can copy the script. And run the command. So now our cluster API compatible GPU image has been successfully created. The name of the artifact is nkp Ubuntu 22.04. We have got an additional suffix, which is GPU, for Kubernetes version 1.32.3, and the timestamp. Head over into Prism Central and we'll see the same image as well. There we go. Right, so we can use, for GPU clusters, we can use this image to build the NKP cluster, and for non-GPU clusters we can use this. So the next step is for us to populate our Harbor Registry with the contents of the Nutanix Kubernetes Platform airgap bundle. So first thing I'll do is I'll log into Harbor. I'll create a new project. I like to keep things neat and tidy, so let's call this mirror. And this is where I'm going to be storing all my Nutanix Kubernetes Platform container images. Then we can head over into the blog. Then there are some commands that we need to run. So I'll just copy the first top two. I've already done the username and password. So that's NKP version. So if we head over to our jump post, we see that the folder name is nkp-v2.15.0. Right, so we can just leave the NKP version environment variable as v2.15.0. The instructions are here. Then the registry mirror URL is the registry that I'm going to be using. So it's registry.wskn.local/mirror. Do include the project name, right? So it's a mirror. And then the next one would be to specify the username, password, as well as the CA chain. I'm not going to do the username and password. I've done that already, but the CA chain is where we need to do. So my certificates are located in /home, Ubuntu certificates, and WSKN CA chain. So just verify, so I can cat, and I see the CA chain. Good. So the next step is to just cd into the nkp by directory. If you're already inside, you just get this error. That's harmless. Then you can just copy all the commands and just let it rip. So the images have completed uploading to Harbor. The next step would be to create the Nutanix Kubernetes Platform cluster. So the last step is to create the Nutanix Kubernetes Platform cluster. So we have got a couple of environment variables to fill up. So we can just click on the copy button, head over into the terminal, and paste that in. Then we can use VI to edit the environment variables. So the cluster name, the first thing that I'm going to do is to change this. I'm going to be using WSKN NKP management. The second one is control plane IP address. So this control plane IP address is going to be the IP address for the Kube API server. The image name can be obtained from the Prism Central, the cluster API compatible image that we created earlier. So head over to Prism Central, our images tab, and I'm going to be using the non-GPU image because this is a management cluster. The Prism element cluster name. So this is the Prism element cluster that we're going to be deploying the NKP cluster on. The subnet name will be the subnet that we're going to be using for deploying into. Control plane and worker replicas and all of the configurations, I'll just leave it as it is. The storage container name is going to be self-service container. So that is the default container that comes out of every NKP cluster, but you are free to change it to something that you want as well. So it's under storage containers, we see there's a couple of containers. There are containers that are created by default. Load balancer IP start and end. So this will be the first IP address will be the IP address of your ingress, the IP address that you use, or the FQDN that you use to access the commander UI, and the ending IP address. Then we can change the Prism Central details. So first one is FQDN for Prism Central. Now, if you're not using FQDNs, which I highly discourage, and use an IP address, in the installation command, you do need to use the -- insecure flag. And if you're using an FQDN and you don't have the Prism Central certificates and is using the self-sign certs, you also need to use the -- insecure flag. So the PCCA, I'll just look for it. And I'm going to use WSKN CA chain because I already have that configured on my Prism Central. We can leave this alone. The Prism Central username and password, I'll just remove those because I already have it exported in my environment variables. The registry URL, so this is your container registry URL, right? So you just leave it as registry.your FQDN, and do not put in the project name at the back, right? So it could be test project, yeah, just leave that alone. Just leave it as registry.your FQDN.local. Then the registry username and password. So I'm still using the default ones. That will change later on. I'm using the same certificate chain, so I'll just copy what I have at the top. In your environment, you might not be, so just make sure you change that as well. This is where we configure the registry mirror for where we are going to be pulling the NKP images from. And this is the CA chain that we have configured for Harbor. Same chain. Then the cluster host name. So this is going to be the FQDN whereby we can access Nutanix Kubernetes Platform, the commander UI. So I'll just call this WSKN NKP mgmt.wskn.local. Then the ingress certificate will be the server.crt. The key will be server.key. And the CA chain will be the CA chain that we have been using all this while. Right. So let's just validate. Looks good. Now if I ping wskn nkp management.wskn.local, I do not get a response, right? Because I do not have a DNS entry that is set up for this hostname yet. So this is very important. You need to make sure that your FQDN is set up properly. So what I'll do is I'll go ahead and set up my FQDN in my DNS server. So the IP address of the DNS that is pointing to should be the first IP address of your ingress, right? So if you take a look at our environment variables again, we see that the load balancing IP range 10.168.100.31, this should be the IP address that I'm using for the cluster hostname, which is FQDN for accessing commander. Okay, so it's 100.31. Done. So when I go back and ping, I should get a response now. Or rather, I should be able to resolve the FQDN. So that looks good. So once that is done, we can go ahead and create the cluster. So we just copy this and head to the terminal and just execute. So I'll fast forward this video. It's going to take about 10-15 minutes, and then we'll come back when the cluster is created. So if we head over into Prism Central, we can see that the first VM should get already been created. Yes, over here. Looks good. And we see a couple more new nodes getting spun up. So that is the worker nodes. So when we see this, initializing new CAPI components, this means that the cluster has been created. If we head over into Prism Central, we will see that we have got 7 machines, 3 control planes, and 4 worker nodes. So what I'll do is I will open a new terminal session to my jump host. And if we were to go into the directory whereby we kicked off the installation, we will see that we now have the kubeconfig file for that particular cluster, right? So we can export the kubeconfig and we can launch something like K9S to monitor the installation. So let us have this side by side. So we take a look at all the ports. You can start to see things starting to come up. And now we see all the platform ads starting to get deployed, right? So Flux, Ingress, and a couple more. Okay, great. So we see that the NKP cluster has completed deployment. We can use this to get the dashboard details. So it's telling me to go to this URL, key in the username and the password. And there we have it, a Nutanix Kubernetes Platform version 2.15 deployed. So we can head over into the licensing tab and upgrade the license. This is only if you have a valid license key to upgrade NKP. Click on activate license and key in a license key. So if I refresh the page, I will see that I have been upgraded up into NKP Ultimate. So the next step will be for us to create an additional workload cluster that has got GPU capabilities. So the first thing that we need to do is we need to create a new workspace. So I can click on the drop-down box here over here, create a workspace. I'll call this WSKN GPU and click on create. So once that is done, I can click on continue to workspace, click on the clusters tab and click on add cluster. Click on create cluster and I'll give it a name. WSKN NKP GPU. SSH username, I will just leave it as convoy, which is the default. The public key, I can get it from my jump host. My node pool for my control plane, I'll just use it as a WSKN management, and I'll use the primary subnet. I'll use the normal non-GPU image, and I'll give it a control plane IP address. So for the worker node pool, I'll just leave it as the defaults for now. For the storage container, I'll just select the self-service container. And for the load balancer starting and ending IP, I'll just fill it up with what I have. and the registry mirror. So this is the registry mirror whereby we are pulling the NKP images from. So I'll just fill it up. And upload the CA certificate, because the CA certificate is a self-signed certificate. And the same for my private registry. And that's it. So this doesn't have any GPUs yet. This is just the base cluster. Once we've created the cluster, we can later then go in and create an additional node pool. So while the cluster is creating, we can head into the cluster under node pools, add a node pool, and I'll call this L40 GPU pool. Select the cluster that I have, which has got GPUs, the subnet, and I'll select the GPU image. I'll select 2 nodes, and I'll give it maybe 16 CPUs and 64 gigs of RAM, and maybe 200 gigs of storage. And I'll select a pass-through GPU. And I'll have 2 nodes. Once that is done, I click on add. And what's going to happen in the background is also going to additionally deploy my GPU node pool. So if we look in Prism Central, we see that the WSK and GPU pool has got the first control plane deployed. It's going to take a while. And here we see the L40 GPU node pool getting deployed, as well as the normal non-GPU nodes. So if you take a look at the configuration, we see that it has got GPUs added as well, and there are 2 GPUs as requested. So we see that the cluster has been deployed, and if we click onto the Applications tab, we can scroll all the way down and enable the NVIDIA GPU operator. So what we can then do is go over to the clusters page and download the kubeconfig. Then I'll head to my terminal, launch a new terminal session, and export the kubeconfig. Then we can launch K9S and see what's happening under the hood. So the nodes are still getting deployed. Check out the nodes. You can see that the control plane is still joining. If we look at the GPU node, we see that there is the 10DE present, which is the vendor ID for NVIDIA. And in a couple of moments, we will see the GPU operator get deployed. So now that the cluster has settled down, we can see that the NVIDIA CUDA validator has ran successfully. If we were to take a look at the nodes, we see that the nodes are labeled properly as well. So we see GPU memory, the family of GPU, and I've got a GPU count of 2. Right? So we can open up the Grafana page as well. It's going to ask me to log in. You can just use the same username and password that I was provided earlier. And if you go to the dashboards and search for NVIDIA, we can see the GPU matrix as well. So that concludes deploying Nutanix Kubernetes Platform in the internet connected environment, as well as deploying a workload cluster with GPU capabilities. Thanks for watching, and I'll see you in the next one.